Okay, we're still on systems of linear equations. This one's a little bit more complicated, only because if I look at these, my goal is to create if my x's have the same number top and bottom, one of them positive, one of them negative. Or my y's, either one is okay, are twins if you will. The problem with this one is I can't figure out a number that I can multiply this one by so that we create twins. Nor can I figure out a number that I can multiply this one by to create twins. Unfortunately, on this one it becomes a little bit more complicated because we're going to have to end up multiplying both of the equations by something in order to create our twins. And I can look at this. My y value's here. Let's see, I can figure out 21. I could multiply this top one by positive 7. I'd have to multiply the entire equation. And then I can multiply this bottom one by a positive 3. And that would work. I could also take care of my x's here. I've got a 3 and a 2. So I know that the lowest number that both of those two will go into is 6. I could multiply my top one by a negative 2 and my bottom one by a positive 3. That would work. So that's what I'm going to choose to do on this one. I'm going to multiply this top one here by a negative 2. Negative 2 times this whole thing here. And I'm going to multiply this bottom one by a positive 3. Now you could have had this one be negative and that one be positive, and that would work as well. I had to choose one, so that's the one that I chose. Okay, now let's do this. Negative 2 times 3x, I'm just going to rewrite it over here, would be negative 6x. Negative 2 times negative 3y would be a positive 6y. Negative 2 times negative 15 would be a positive 30. Okay? That one's done. I've just multiplied everything by negative 2. Now I go to this one here and I have to multiply this first one. 3 times 2x would give me 6x. And I'm going to line them up so it's nice and neat right underneath each other. 3 times 7y would be positive 21y. And then 3 times 8 would give me 24, positive 24. Okay, now on this one, now I have my same number on top and bottom, my coefficient. One is a positive, one's a negative. So when I add those two together, they cancel out. So now I've got a 6y plus 21y would give me 27y. 30 plus 24 would be 54. Now I would divide both sides by 27. That would give me y equals 54 divided by 27 is 2. So now I know that y equals 2. With that knowledge, I can plug that into any of these equations here. This one, that one, or that one. For y, to find out what x equals. Since this one appears to be the cleanest at the moment anyway, I'm just going to choose this one. Okay, so I know that y equals 2. I'm going to copy down this equation right here exactly as it's written. I didn't change anything on it, I just wrote it all down. But now I know that y equals 2. So instead of writing y, I'm going to write what y equals. 2x plus 7, and it's 7 times y, so it would be 7 times 2 equals 8. Now I'll simplify it further. 2x plus 14, 7 times 2 is 14, equals 8. Now I'm just solving for x. Subtract 14, and what I do to one side I have to do to the other side. 2x equals, that would be a negative 6. 8 minus 14 is negative 6. Divide both sides by 2. X equals 3. And again, you can write it this way. You can go x equals 3, y equals 2, and that would be an acceptable answer. If you choose to write it as an ordered pair, it would be, let's write it over here, 3, 2. Make sure you have parentheses on them, and that will be your answer. So it's a little bit more complicated only because we had to multiply both equations, but as long as we do it to all parts of the equation, we're fine. It will work.